You're inside your VM, running as root, with complete control over the operating system. You want to see what's happening at the hypervisor level, check CPU scheduling, inspect memory allocation across VMs, verify network isolation between tenants. You can't. There's no command for it, no API endpoint, no escalation of privileges that gets you there. You've hit an abstraction boundary, the hard interface between the guest OS layer, where you have control, and the hypervisor layer, where you have none. The boundary isn't a suggestion, it's an architectural wall. One side is your domain, the other side is off-limits. And that wall exists everywhere in cloud computing, separating layers, isolating tenants, enforcing security, and sometimes creating problems when you legitimately need to understand what's on the other side. Let's talk about where these boundaries are, why they exist, and what happens when you interact with them. An abstraction boundary is the interface between two layers of abstraction, where one layer's exposure ends and another layer's implementation begins. It's the line that separates what you can see and control from what's hidden and managed elsewhere. Think of a boundary as a door between rooms. On your side of the door, you have full access. You can arrange furniture, paint walls, control everything. On the other side, you can't enter. The door has a specific interface, maybe a doorbell, maybe a mail slot, that lets you communicate through the boundary, but you can't cross it. In cloud computing, these boundaries serve three critical functions. First, isolation. Boundaries separate tenants from each other, ensuring your workloads can't access or interfere with other customers' systems. They separate privilege levels, ensuring low-privilege users can't access high-privilege operations. Second, simplification. Boundaries hide complexity. Everything below the boundary is invisible, letting you work with simpler abstractions without needing to understand implementation details. Third, enforcement. Boundaries enforce security policies, resource limits, and architectural constraints. They're not just conceptual, they're implemented through code, hardware features, and access controls that actively prevent boundary violations. Understanding boundaries means knowing where your authority ends, what interfaces exist for crossing boundaries legitimately, and what happens when boundaries fail or get violated. Cloud computing has multiple types of boundaries operating simultaneously at different layers. Layer boundaries separate abstraction layers in the stack. The boundary between your VM's guest OS and the hypervisor is absolute. You can't access hypervisor resources from inside the VM. The boundary between your application code and the runtime environment controls what system calls you can make. These boundaries enforce the abstraction stack we discussed in the last video. API boundaries are how you interact with services. The cloud provider exposes specific API endpoints, create a VM, upload to storage, query a database. Those endpoints define the boundary. You can request things through the API, but you can't directly manipulate the underlying systems. The API is both the boundary and the interface for crossing it in controlled ways. Service boundaries separate different cloud services from each other. Your compute instances operate in one boundary. Your database service operates in another. Your object storage operates in a third. These services interact through defined interfaces but maintain internal isolation. You can't SSH into the VM that's running your managed database that crosses a service boundary the provider doesn't expose. Tenant boundaries isolate customers from each other, the most critical boundary in multi-tenant cloud. Your VMs, storage, and data are separated from other customers' resources. This boundary must be absolutely secure. Violations would be catastrophic breaches. Hypervisor isolation, network segmentation, and access controls all enforce tenant boundaries. Permission boundaries control what actions authenticated users can perform. You're logged in, you're inside your own tenant boundary, but you still can't do everything. IAM roles, policies, and resource-level permissions create boundaries within your own environment. Some actions require crossing permission boundaries by proving you have appropriate authorization. Geographic and regulatory boundaries define where data can reside and be processed. Jurisdictional boundaries enforced through region selection and compliance controls. You choose to operate within certain boundaries to meet regulatory requirements. Each boundary serves a purpose, and each creates interfaces for legitimate crossing while preventing unauthorized boundary violations. Boundaries aren't just static walls, They're active interfaces where important things happen. Translation occurs at boundaries. When you make an API call to create a VM, your high-level request, "I want a T3.medium instance," crosses a boundary and gets translated into low-level operations, allocate physical resources, instantiate a VM, configure networking, start the OS. The boundary takes your abstracted request and converts it into concrete implementation actions you never see. Validation happens at boundaries. Before your request crosses, the boundary checks. Are you authenticated? Do you have permission? Is your request well formed? Are you within quotas? The boundary enforces rules about what can cross and what gets rejected. Context switches occur at boundaries. Crossing from user space to kernel space in an OS requires a context switch. Changing privilege levels, switching memory contexts, crossing from your application to a cloud service API involves similar transitions, though abstracted. These switches have performance costs, observability changes at boundaries. Inside your boundary, you have full visibility. Across the boundary, visibility depends on what the other side exposes. You can see your application logs, but you can't see cloud provider internal logs unless they choose to expose them through CloudWatch or similar services. Failure domains meet at boundaries. Problems on one side of a boundary don't always propagate to the other side. Boundaries can contain failures, but boundary failures themselves can be catastrophic because nothing can cross if the boundary breaks. API outages are boundary failures that prevent any interaction between layers. Trust relationships exist at boundaries. You trust the provider to properly implement boundaries. The provider trusts you to use interfaces correctly. When you make an API call, you're trusting it will do what it promises. When the provider exposes an API, they're trusting you won't abuse it to cause problems. Understanding boundaries matters most when things go wrong. Boundary violations occur when security breaks down and unauthorized crossing happens. A VM escape vulnerability lets code break out of the guest OS boundary and reach the hypervisor. A privilege escalation lets a low-permission user cross permission boundaries they shouldn't. These violations are security incidents because boundaries are security controls. Boundary failures happen when the boundary itself stops working. An API outage means the boundary between you and the service is non-functional. You can't cross it legitimately, leaving you unable to manage resources. Authentication system failures close the permission boundary, locking everyone out. Boundary confusion happens when you don't understand where boundaries are. You assume you can access something, but you've hit a boundary you didn't know existed. You're troubleshooting a performance problem, but the cause is on the other side of a boundary you can't see across. Boundary mismatches occur when abstractions don't align with reality. The API suggests you have certain capabilities, but boundary enforcement prevents you from actually using them. Or you're promised isolation, but boundary implementation is weaker than advertised. Legitimate boundary crossing challenges happen when you genuinely need information or control on the other side of a boundary for valid reasons, but no interface exists for getting it. You need to verify physical host separation for compliance, but the boundary doesn't expose that information. You're stuck. Not because you're doing something wrong, but because the boundary doesn't support your use case. The most frustrating boundary problems, when you can see a problem happening on the other side of a boundary, but can't reach across to fix it. The boundary protects you from risks, but it also prevents you from solving problems. Abstraction boundaries are the walls between layers, the interfaces between domains, and the enforcement points for security and isolation. They define what you can control, what you can observe, and what you can never touch. Every API you call crosses a boundary. Every service you use operates behind boundaries. Every security control depends on boundaries holding. Understanding where these boundaries are and how they work is fundamental to cloud architecture. And remember, boundaries aren't obstacles to work around. They're architectural features that make cloud computing possible until they get in your way. See you next time.